Hello. In the previous lectures, we talked about the basic hierarchy of memory and basic classification of memory, and then we moved on to the structure of a memory array, right? So how, for example, if you have a one kilobyte memory or 1 kilobit memory, how it was implemented, things like that. And during all those discussions, we just considered that there is one element which is capable of storing and retrieving one specific bit, whether it is 0 or a 1. That is, there is a memory element to which if you give a 0 or a 1, it will be stored and it can be retrieved when it is required. And for accessing these elements in the arrays, we used write lines and bit lines. So in this lecture, what we will be doing is we will be examining how we can implement those single bit storage elements. Okay. Now, depending on the type of storage in a memory, there can be two types, right? That is, one is volatile and the other is non-volatile. Okay. The volatile type of memory is called as a RAM, and RAM stands for random access memory. Okay. Here the name random access doesn't have anything to do with the volatile fact. It just so happens that one of the random access memories that we use, it is a volatile type, but now the convention of naming has been set. It so happened that volatile memories, we call them as RAM, and non-volatile memories, we call them as ROM. Okay, so what is RAM and what is ROM? Before that, what is volatile and what is non-volatile? Volatile means whatever memory you are storing in that, whatever data you are storing in that memory, it will be present till the power is on. That is, if you have stored something in your RAM in your computer, and the moment you switch off the the moment you switch off the computer, the content of the RAM is lost. Whatever data is stored in the RAM is lost, right? That is a volatile memory. Volatile memory is a memory in which the content is lost once you power it down. And non-volatile is obviously the opposite. That is, once you store it, even when you switch off the power, it will be there. And when you power back the system, you can access whatever was stored in the ROM. So RAM and ROM. The thing is that ROM is also a random access type of memory, right? Random access means you can access or the time taken to access any memory location is the same. This is opposite, or this came as an improvement over something that is called as a sequential access memory. It is magnetic disk, magnetic tape recorders, things like that. Those are actually sequential access memory. But RAM and even ROM, the full form of ROM is read-only memory. Even ROM is a random access device, because also in a ROM, the time taken to access any memory location is the same. But for the sake of discussion, ROM, that is read-only memory, it is a non-volatile memory, and RAM, random access memory, it is a volatile memory. ROM is non-volatile, RAM is volatile. But remember, for both RAM and ROM, access is random only. That is, the time taken to access any given data address location is the same. Okay. And the other thing is that both RAM and ROM come under primary memory or main memory. Earlier in the hierarchy, we had shown that in the main memory we had given only RAM, but in any practical computing system that is not possible, and we need some sort of ROM to be there in the main memory, because when a computer system starts up, there won't be anything in the RAM, right? And the processor goes towards and searches for instructions to be executed from the main memory. So for starting things like your boot up, your bootstrapping, things like that, data should be there in the main memory, and for that we use ROM, right? So that is the thing. Main memory as such as we use it today is a combination of both ROM and RAM. Okay, now moving on. First we will take a look at the different RAM technologies in detail, little bit detail, then we will move on to the types of ROMs. So two types of RAM that are now popularly used are dynamic RAM or DRAM, and the other one is static RAM or SRAM. Okay, dynamic RAM and static RAM. So if you remember, the hierarchy, cache was implemented using a static RAM, right? So we'll see them one by one. Okay, this is a comparison between the internal structure of a single bit of storage using DRAM and SRAM. Okay, so the structure of a dynamic RAM is there is a MOSFET connected to a capacitor. That is it. It is very simple. And depending on the charge being stored in the capacitor, the value will be either 1 or 0. But when it comes to an SRAM, there are two MOSFETs here and two inverters here, coupled in sort of like a loop. So whatever you are storing here, it is sort of reinforced by both, and it will be stored in this part. The thing is that dynamic RAM has to be refreshed. The value in the dynamic RAM has to be refreshed periodically. Otherwise, the whatever value is stored will be lost. But in a static RAM, that is not required. Once you give a data, you store a bit, and as long as the power is on, unless it is for a very long time, you don't have to refresh the bits. That is, you don't have to reload the RAM bit. In this one, you have to refresh every now and then. But the thing is that advantage of a DRAM is that it is very simple, in the sense that only one MOSFET and one capacitor is required for implementing one bit. But here it is more. You have already two MOSFETs are here, and you have to implement two inverters. And DRAMs are slower, SRAMs are faster. Okay, here is a comparison of the number of transistors. Transistors here means MOSFETs, and the time latency, that is how fast or slow it is. So flip-flop, obviously it is much faster, but it requires a lot of transistors. And SRAM, it requires 6 MOSFETs per a single bit, but it is fast. It is slower compared to the flip-flop, but it is faster compared to the DRAM. Again, DRAM is very easy to implement, but it is slow. In modern computing systems, we don't usually use flip-flops for storage. We go with storage means memory here. Sorry, we go with SRAM for the implementation of cache and register files, and DRAM for the implementation of main memory, regular RAM, the thing that we call RAM, right? So main memory, again, it's not only RAM, there will be some ROM also, right? So that is SRAM used for register files, implementing register files, and cache memory. Then DRAM, it is used for implementing our main memory, RAM used in the main memory. And these bits, single bit implementation of an SRAM and a single bit implementation of a DRAM. Okay, now moving on to read-only memory. So the thing with ROM is that even when you power off the device, the memory is not lost, right? So in RAM there is requirement for the power to be on, and this is a simple implementation, or this is a basic implementation of a ROM. That is, if a bit cell contains 0, then there should be a transistor here, right? That is grounded, otherwise there won't be a transistor. So how is this implemented? That is the main part. The other thing is that historically, that is in earlier times, ROMs were not programmable. In the sense, if you wanted some data, if you wanted something, once you write something into the ROM, that was it, and you required special hardware for writing something into the ROM. And once you have used the ROM, that is, once you have programmed the ROM, you have entered some data or instruction or whatever into the ROM, you couldn't change it. So it depends on the implementation of this part, how you can implement the presence of this transistor being grounded or the absence of this transistor. Depends on that. Different types of ROMs are there. This is a notation regarding a ROM. Okay. The idea is that once it is programmed, the data won't change. So this is just a notation, and there is no other meaning for this. So this means that in the location 1 1, the value is 0 1 0. The location 1 0, it is 1 0 0. Location 0 1, it is 1 1 0. And location 0 0, it is 0 1 1. And I have already mentioned in the previous lectures the purpose of this decoder and how addresses are coming. Okay, this is an implementation of ROM using logic gates, right? So in this thing, how do you want what is the purpose of a ROM? The thing is that whatever device it is, you give some data, some address, and you get some output, right? So here let's see what happens. If you select the line 1 0, okay, you have selected the line 1 0, then the input to not the input, the value at this line will be 1 and the value at every other line will be 0, right? So what happens? This one comes here and this will become a 1. If this is not, I don't think it is connected here. No, it is not connected here. No, this is not connected here. So there will be 0 here, and anyway this is a 0. This is only connected to this. So 1 comes here and 1 or 0 is 1. This is not connected here. So 1 0 or 0 or 0 is 0. It is not at all connected here. So it is 0. Then what happens? If the selected line is this one, so 1 or 0 is 1, 1 or 0 or 0 is 1, then nothing is connected here, so 0. So this is how you implement a ROM using logic gates. This also can be done. So like I mentioned earlier, ROM historically or in the earlier times, ROM, once it was programmed by the manufacturer, you couldn't change it, right? So then what came is a programmable ROM, PROM, programmable ROM. So the idea with programmable ROM was that, see earlier in the image what we told, you have this basic block, right, basic cell. So for that cell to be 0, this transistor had to be grounded, right? Here, this end of the transistor had to be grounded, and for this cell to be 1, this end of the transistor, this transistor should act like it doesn't exist. So if you just keep this floating, that is, if you don't ground this, then effectively this is non-existent. So that is the idea. For that, what manufacturers did was they gave a fuse here, right, a sort of fuse. So if you kept the fuse intact, then this cell was a 0, and if you blow off this fuse, that is if you melt off the fuse, then this cell was a 1. So this programmable ROM, when you buy it, it would be all zeros, and depending on your purpose you can program it one time, right? So you didn't have to go to the manufacturer to get a programmed ROM. You could do it yourself, and it was done using UV, ultraviolet rays. There was a specific machine that you could buy, and you could program your own ROM, right? That is a programmable ROM. So we saw a basic simple ROM which was programmed and manufactured and given to you by the manufacturer, so that you couldn't do anything. Then there came a programmable ROM, that is you could program it once using some sort of a ultraviolet ray emitting machine. There was specific machines for doing that, and an example that we saw was the fuse programmable ROM, right? And then came the erasable ROM, EEPROM. So in EEPROM, what happened is that instead of the fuse, they used a floating gate transistor. So this was a sort of a reprogrammable ROM. So in a regular PROM, that is a programmable ROM, you could only program it once. Once you have programmed it, then that was not changeable. But then came this one, reprogrammable ROM, and here also an ultraviolet ray was used to change the float configuration of the floating gate transistor, which was used instead of the fuse. And the next one is the electrically erasable PROMs, that is EEPROM, right? So this is something that is, you didn't need this machine emitting ultraviolet rays or anything. You could program it electrically or electronically, let's say. And so you obviously you may require some specific machinery for that, but still it was becoming more user friendly, and you could reprogram it multiple number of times. Then there is this flash memory, which is used in your pen drive and things like that. So it is used for storing more data, right? So these are the types of ROM: regular ROM, programmable ROM, erasable ROM, that is ROM, programmable ROM, which is PROM, erasable programmable ROM, which is EEPROM, then electrically erasable programmable ROM, EEPROM, and the last one is flash memory. So these are the different types of ROMs, and with this I am winding up the session on main memory. So what are the things you have to remember in main memory? The hierarchy of the main memory, the types of main memory being used, then coming to RAM. When you're talking about the hierarchy, cache memory, main memory, and secondary memory. Secondary memory or virtual memory. Secondary memory is better. Then in main memory, there is usually people say it is RAM, but in practical scenarios, ROM is also there. Some sort of ROM will be there, and cache is there. Then when it comes to implementation, there are two types of RAMs, SRAM and DRAM. SRAM is used for implementing registers and cache memory. DRAM is used for implementing the RAM part of the main memory. Then ROMs are of multiple types, and the ROMs that are used in modern computing systems, whether it is a smartphone or your computer, it is a EEPROM, because here you are able to rewrite it many times, right? Even your mobile phone, you are rewriting it. Every time you are flashing your mobile phone, or every time you are updating the BIOS, or the boot part of your computer, you are actually you're changing or you're updating the ROM. So that is also a part of the main memory. At least some of it is there. So that is the types of memories. Then remember the concept of random access and sequential access. Even though we classify RAM and ROM as two types of memories, yes, there are two types depending on the volatility, but depending on the type of access, both RAM and ROM are random access devices. So in the next lecture we will deal with cache memory. Thank you.